Okay, first, verify this. Okay, can I have attention? Can I have your attention? I know it's printed for you, tendency is not to listen and talk, okay, but just control that a little, okay? To verify this is not difficult. I just make these two fractions have a common denominator and then combine the numerator, simplify the numerator, I will get this. Okay? Can? Not difficult. Second part. Hence, find the sum of the first n terms. There must be one last term somewhere which I don't know. This is the nth term. There must be one last term that I don't know. This, because it says the sum of the first n terms. So, can? All okay? Now, notice in the solution, you have, it's already printed for you here. But can we take some time to look at how this term is being formed? How do you write it out on your own? Suppose you don't know this. Are we able to write this last term on your own? Can? How? I will focus on the easiest term. This is 1, oops, sorry. This is 1 squared, this is 2 squared, this is 3 squared. Last term must be n squared, quite obvious. This is 2 squared, 3 squared, 4 squared, this must be n plus 1 squared, quite obvious. Correct? Because you know you have n terms. You have 3, 5, 7. These are odd numbers. This forms an AP. The nth term, if you consider the nth term of an AP, you will get 2n plus 1. You surely must get 2n plus something because the AP has a common difference of 2. Correct? So you have 2n plus, it may be 2n plus 1, 2n plus 3, or 2n plus something. But in this case, it's 2n plus 1 because you sub n equals to 1, I get a 3, n equals to 2, I get a 5. Understand? Understand how I come out with that expression? So with that, then I can write this. Sum 2r plus 1 over r square r plus 1 square r equals to 1 to n. Can? Not difficult to see. Not difficult to see. Questions? All okay? Can? Now, in the earlier result, we have shown, look here, 2n plus 1 over n square n plus 1 square is this. So 2r plus 1 r square r plus 1 square, I just change the n to r. Follow what I'm saying? Can? So I just change all the n here to r. This looks exactly the same. So (1 over r square minus 1 over r plus 1 square. Okay, the next few lines are printed, so I want you to pay close attention to what I'm saying and make notes. Okay, as we go along. How do we know we need to use method of differences? First, we look at the minus sign there. 1 over r squared minus 1 over r plus 1. There is a minus sign there. If it is a plus sign there, then don't bother using the term because you will never use method of differences. Because there's no difference. Right? There's a minus sign there, so 1, 2 there. Next, if there are two terms here, and the two terms look more or less similar, they are quite successive. One is r plus 1. We suspect that we use method. So these 2 points I say again. First is there is a difference, there's a minus sign. Second is the two terms are quite similar. One is r, one is r. What follows next? What follows next is I'm going to write term by term. Which means I'm going to write substitute R equals to 1. Substitute R equals to 1. Into this, I get 1 over 1 square minus 1 over 2 square. In a next line, so please don't write everything in one line, can? Write all one line per value of R. For each value of R, write a new line. I repeat one more time. For each value of R, write a new line. Okay, maybe I write down. Maybe it's easier. Write one line for each value of R. Like that. Okay? Can? One line for each value of R. So when R equals to 2, you write in a new line. R equals to 3, I write in a new line. And don't forget to write the last few terms. You not only write the first few terms, you also write the last few terms. Which means I substitute R equals to n minus 2, R equals to n minus 1. I substitute R equals to n. So I'm not going to elaborate how I get all these terms. You substitute, you will know. Not difficult. So, can I repeat? Write first few lines, write last few lines, and then for each value of R, write a new and use a new line. Why do I force you to do that? It's because, as I have demonstrated in the introduction example, you can see this plus minus this, I get 0. Can you please also draw the line to cancel off on your notes? You have to show it that you can see this pattern. Then you ask, what about minus 1 over 4 squared? Will it be cancelled off? Yes, because you expect the next term to have 1 over 4 squared. So this one goes. And then this one goes. This one goes. What about this minus 1 over n minus 2 squared? Will it go? Yes, because with the previous term which we did not write, it should go. What we are left with is this and this. Magic, right? So nice, right? Beautiful. Math is beautiful. Right? Therefore, my answer is 1 minus 1 over n plus 1 squared. Actually, this expression already quite nice. If the question didn't ask you further, actually, I'm quite happy with this. I really am. But never mind. If you want to simplify a bit further, if you want to make it into a common denominator, then we can, then we can still do it. N plus 1 square minus 1 over n plus 1 square. Okay, looks a bit nicer, but to me, this one and this one, I am okay. I really am okay. Can? Is that alright? Get the hang of it. The method of differences, quite nice, right? Quite fun, huh? Okay, example 6. Okay, I promise if I can complete example 6, I will let you go early. 8 minutes left. Can. Maybe you use 6 minutes, I let you off 2 minutes early. Okay. Shh, thank you. Okay. Verify this. Some of us are very afraid of factorial. Can you tell me, how do we simplify this? Thank you. Example, what is 11 factorial? 11 factorial is 10 factorial times 11, am I right? Can? So therefore, r plus 1 factorial is r factorial times r plus 1. Why do I do that? I want to create the r factorial out. Yes, I want to have the r factorial out. Then I can factorize the r factorial. And then I have r plus 1 minus 1. Then I have r times r factorial. Got it? Okay, next. Find the sum of the first n terms of this guy. Again, there is no last term here, so this one I will leave it to you to see how to get this, which is actually very easy. Correct? Last term must be, because there are n terms, this is the first term, second term, third term, nth term must be this. Quite obvious. Then you change it into a summation sign, r times r factorial. I think you know the drill by now. This should be the same as this. Hence, that means you got to make use of this result. Equals to r plus 1 factorial minus r factorial. Now, again, the question will never say use method of differences. No, so you have to again spot that. Okay, I have a summation, I have minus, I have two terms that look more or less the same. They are just successive terms. Then you suspect use method of differences. This start r equals to 1, r equals to 2, r equals to 3, first few lines, and then r equals to n minus 2, and r equals to n minus 1, okay? So we write. If you are fast enough, can write. No problem. Don't worry about it. Can write. Okay? You have 2 factorial minus 1 factorial plus 3 factorial minus 2 factorial plus 4 factorial minus 3 factorial. Don't forget the plus dot dot dot, okay? I'm going to continue this side, okay? I'm going to continue this side. Plus n minus 1 factorial minus n minus 2 factorial plus n factorial minus n minus 1 factorial plus n plus 1 factorial minus n factorial. This is r equals to 1, this is r equals to 2. The r equals to 1, 2, 3 optional, you don't write, doesn't matter. Okay, just for your own notes. Make sure you list the first few terms and last few terms. Okay, you don't have to write the brackets. Really don't have to. But I write it just to be clear, just for my explanation. Now, then it's not difficult to see this pattern of cancellation, which is opposite direction as just now, but never mind. 2 factorial, 2 factorial, 3 factorial, 3 factorial, 4 factorial goes, this one goes, and this one should go with the term above. What we are left with is minus 1 factorial and this. And then you get the answer, done. Any questions? All okay? Good. Okay, we have the exam today. Well done. Then you got 3 minutes. Thank you.